Let's move on to number 3, Trigo identities. This only happens when you have a expression that involves Trigo. Okay, now pay attention here. I said that it only happens, okay, this technique can only work, okay, when you have trigonometries in the expression. That's obvious, but that doesn't mean that whenever you have trigonometries in your expression, okay, the deduction must be this technique. All right, so be careful here. It could be some other techniques, but in order for you to use this technique, you must have Trigo in your expression. Okay, so let's take a look at this guy over here. So again, in the front part, you're asked to work this out. You figure out that this is your answer. They ask you to deduce, okay, hence deduce e sine square x. So in this case, what we need to do is to look at what is the relationship between this and this, right? And we know that there is actually an identity that relates the two, which is cosine 2x is equals to 1 minus 2 sine square x. So we can make sine square the subject of the formula. So sine square x is actually equals to, we move this over to this side and then we move this over to the other side. Then after that we divide by 2, that gives us half. Okay, then we move this, is minus, right? So it's minus half cosine 2x. Okay, all right. Okay, if you need time to evaluate this and check that this is correct, just go ahead and do that. Okay, so we move this over, move that over, and divide by 2. Okay, now for this, in this case, we can simply replace this, all right, with e to the power of half minus half cosine 2x, all right, cosine 2x. Okay, so as a result of that, we can go ahead and work this out. We know that e to the power of half is just square root e. Okay, so I'm going to erase this. All right, we already have that. So let's go ahead and erase this. Okay, we have e to the power of half, which is e to the power of half over here, and then bracket, okay, e to the power of half cosine 2x. Okay, and then we have a minus over here. So in fact, you can see this as if it is e to the power half cosine 2x, all right, close bracket to the power minus 1. Now if you multiply that, the indices back in using the laws of indices, this at the back is equal to this part over here, right, minus half cosine 2x. Okay. Okay, so we're gonna copy down the e to the power of half. Okay, I'm just gonna write it as square root e. Okay, and then after that, we're gonna replace e half cosine x, 2x with the expression that we have. Okay, so we will have square root e minus square root e x squared plus dot 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 to the power minus 1. Okay, so in order to expand this, okay, or rather simplify this, we see that from our MF26, right? We will have to use the equation. Okay, I'm going to write it over here, right? If MF26, the formula sheet has this, okay, for the Maclaurin expansion, which is 1 plus x to the power n, and then we know that it's 1 plus nx, okay, plus n bracket n minus 1 over 2 factorial x squared plus dot dot dot, okay, so on and so forth. So we are not done for this question, but the technique of using the Trigo identities is covered here. Okay, we have essentially changed the sine square to the cosine 2x, right, as I've mentioned. So in order to finish this, let's go ahead and use this, all right, to simplify this expression. Now in order to get the 1, we will need to pull out the square root e. Okay, to pull out the square root e, what happens is when you pull out the square root e, okay, the minus 1 is being applied here. So when you pull that out, it's actually square root e to the power of minus 1, okay, for this one over here. Then when you pull it out and multiply it with the square root e, it actually cancels out and just pretty much leave you with 1 minus x squared plus dot 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 minus to the power of minus 1, okay? All right, when you pull out the square root e, okay, from here, it will give you square root e to the power of minus 1, all right? And then the square root e to the power minus 1 that you have pulled out, multiplied by square root e, cancels out because it's equal to 1. So then you have this, okay? So let's just go ahead and use this to expand this, all right? So we have 1 which is the 1 here, then the x, we're going to replace it with minus x squared, okay, and our n value is minus 1, okay, our n value is minus 1. So we have 1 plus n, which is minus 1, and then the x is replaced with this, which is minus x squared, okay, then plus, okay, the question only asks us to do up to x squared, so I'm going to just leave it at that, because the next one, when you have minus x squared, is going to give us x to the power 4, so that's not required. So let's go ahead and just simplify this. So our final answer would be 1 plus negative negative, okay, so it's positive x squared plus dot dot dot, okay, so there you have it. That's how you use the technique of Trigo identities for questions like this, okay.